Welcome to Class 7, where the main topic of today's session is cameras. And I'll walk you through some camera controls and camera technology. But first, I want to pick up on one or two little missing things from the grading session and one or two complexities that I realized I meant to talk a little bit about relating to these so-called quotes, contrast and brightness, which are just the most horrible words that we have in digital imaging because they potentially mean so many different things implemented so many different ways by so many different people. So let's start with the reminder from the previous class on grading that the knob called contrast rarely or never controls what corresponds to visual contrast. If you had to pick one control which had a dominant effect on visual contrast, you would pick gamma, although strangely the brightness control has got some effect on visual contrast as well. And if you had to pick one control which had a dominant effect over the visual quantity or attribute, really brightness, the control you would pick is contrast. How strange. So at least in grading, we used a knob labeled gain to tell us where the top end of each of the three channels, red, green, and blue, is located. But gain then corresponds in a display to where the white patch is going to end up. And so if you want to calibrate a display to be useful for HD grading, you'll want the white patch to be around 100 candelas per meter squared. And this monitor is probably delivering a little more than that, but we haven't measured it, nor will we bother to. Now, to measure black, you might think, well, how could that be a challenge? Black is just no light. But in practice, you've already heard in the earlier classes that we have physical characteristics of displays that splash unwanted light into pretty much everything, including unwanted light in what should be perfectly black. So we never get a perfect black. And our best example of the black we can achieve is the black that's lurking down here at the bottom of this screen. But there's a little segment here which is blacker than black and a little segment which is lighter than black. And these little segments are called the picture line-up generator, or PLUGE. And that's a quaint English term invented 40 or 50 years ago, even lining up black and white monitors. And we still use it today if there's any risk of the monitor black level drifting. And so in an HD test pattern like the SMPTE 219 pattern, the picture lineup generator portion of the test signal is supposed to go down to -2% on the video signal scale for a brief period of time, up to +2 and up to +4, which, by the way, is the historical SD PLUGE setting level. Now, from 0 down to -0.02 should be completely indistinguishable. So black level set correctly will be such that you simply cannot see that patch unless you raise the black level by artificial means. The +2% bar is simply a check after the fact. It's not actually used during the adjustment. So you'll make that PLUGE adjustment, and unfortunately, I wish I could say, well, you'll always make that adjustment in the black level knob. But even Sony displays, studio displays, $40,000 displays, still use the word bright, short for brightness. But you're doing nothing with brightness, it's black. So it should be called black level. And on digital consumer LCD displays today, we don't even need to have a control for that. They're still useful in HD mastering because we want to be really precise on HD mastering and kind of overcome the ambient light level to make that correction of the -2% and the 0. But in consumer computer displays that are used with digital interfaces, basically nothing drifts, or it doesn't drift enough to make any difference. In fact, it's really a bad idea to have a black level control because it'll only confuse the consumers. It gives them one more control to manipulate. So Apple led the way here, and recently they've been followed by other consumer display manufacturers such as Dell in just deleting the black level control. It's just not there. And then Apple labels the remaining control just with an icon, not with a word, because Apple are thinking of international product development. But unfortunately, the icon they've chosen for the remaining knob is the icon that was historically used for black level, or so-called quotes brightness. So it's all pretty confusing. And, I give myself license to talk about these issues in this course, even though this course is called Introduction, because these are exactly the issues that trip up people who are just learning how all this stuff works. And I must say, people who are just learning tend to think, all of this must be really carefully designed and sensible and standardized by now. And none of those things are true, actually. So then using the example Dell, Apple, as I said, led the way, but they don't even use words. They just use icons. And modern Dell displays typically also do not have a black level adjustment at all and have what they call brightness, which is now adequately representing what that knob does, but historically that would have been called contrast. So then digging into the display that we're using today, this is basically a commodity consumer electronics television display. And we can call up its menu, we can go into the picture menu, and we find not only brightness and contrast, but also backlight. Now, this backlight control is really dangerous. It's referring to adjustment of the luminance of the backlight behind the LCD modulator, where the brightness and contrast adjustments are implemented in the signal path in front of the LCD. But assuming the LCD is set up to have a gamma function, the backlight just multiplies the transmittance of the LCD to determine how much light you see. But the contrast control, so-called, also just multiplies that amount of light. So in principle, those two knobs should do exactly the same thing. And why they're separated out into two different adjustments, we don't know. So now returning to the brightness and contrast controls, we can assume fairly safely that these two controls are exactly black level for brightness and gain for contrast. And so it's the contrast control that exhibits a dominant effect on the luminance of the white patch. And if you want to line this up to use as a mastering monitor, well, first of all, I wouldn't recommend you use this display as a mastering monitor. But, you'll get similar displays of the control values on all sorts of different display devices, including ones which are advertised for HD mastering. So now let's go to brightness, which we believe is black level, access that control, and crank it up. And if you watch what's happening with the picture lineup generator, you'll see there's dark gray, darker gray, lighter gray, but there's only 2 bars instead of 3 bars. So what's going on here? Well, what's going on is the interface that we're using from my computer into this display doesn't have any footroom region. So the minus 2% gets clipped. It never gets displayed. So you cannot set Plooge with a signal that's come out of a computer in CE or IT. In IT or PC range, because the minus 2% just got clipped. So that's one reason to accommodate footroom, is to allow you to handle the Plooge signal to be able to line up a monitor. And there's several other good reasons. That's just one reason. Now, coming out of black, let me give you a little teaser on 18% gray. I've said several times in the course already that 18% gray, such as the background of my Camet chart, is important as living perceptually halfway between black and white. And there's a little bit of arithmetic behind that. For those of you who know what a geometric average is, 18% is the geometric average of a very dark black reflectance, 3.6%, and a very light white reflectance, 90%. So when I say perceptually halfway, it is really exactly halfway on the logarithmic scale between the darkest practical black and the lightest practical white. So that's a teaser for logarithms, which we'll discuss in some detail in class 10. Another way of thinking about 18% is if you take that as your reference point, then white is 2 1/3 stops up from there, and black is 2 1/3 stops down. So this gives you a starting point for thinking about how that range of black and white reflectances can be placed in the capture of a scene in the dynamic range, in the exposure range available to the camera. And so that takes us into cameras. And so now let's talk about the controls available in an HD camera to adjust where those light values or reflectances lie on the code scale available to the camera. Now, BT709 is a standard which I must say is very confusing because it talks about chromaticity values, and those would be chromaticities of the display-referred image data coming out of an HD camera, which we hope are exactly the chromaticities used for display. What 709 does not talk about, and honestly should talk about, is what's the gamma of the display, the reference display itself. And only a few years ago did a standard finally get established, BT1886, which says basically thou shalt use 2.4 gamma to master HD in a studio class viewing environment. There is a bunch of stuff in 709 about gamma. It looks like this if you plot it, and you find in the 709 spec an equation that looks like this, that says how to map linear light values to video values. And it's got an exponent in the equation 0.45. That value is available in a camera for adjustment of gamma, but the effective value of gamma is influenced by what's the scaling and what's the offsetting around that number. So even though that's the number that shows up in the menus, I call it the advertised gamma value, the effective value of that whole curve is very close to 0.51. So those numbers are somewhat different. And to really capture HD well, you need to understand a little bit about that difference. Now, in practice, people don't use the factory settings. They wing all the knobs. And so let me give you a very brief introduction to what those knobs are. There's mid-scale gamma or master gamma, and it ranges something like from 0.4 to 0.5. And this alters the contrast and color characteristics of the image. Now, even though it's gamma, doesn't mention the word color, when you dial in or dial out gamma, you do affect the colorfulness of the image data. Now, there's also controls available for basically what happens in the shadows and what happens in the highlights. And you've already heard in grading class that the gamma controls are available on all three channels. And even in the grading system, there are more detailed adjustments available for what happens in the shadows and what happens in the highlights. But in a camera, the shadows are controlled by what's called black gamma, and the highlights are what's called Ni. So for some reason, we use parts of the body from Ni, or I should say from toe to knee in video, and we don't talk about the rest of the body, just toe to knee. So some people will refer to this region of the curve as the toe. And that's also a common film term, but for some reason I don't understand, the highlight characteristics of film are described as shoulder instead of knee. So figure that out. That's just the terminology that people use. Now, again, I warn you, as I've mentioned several times already in the course, if you allow the acquisition camera operator, DIT, videographer, DOP, to mess around with those controls, we don't even today, in 2014, have a good metadata story for whether that information is carried forward into the DI and post chain, or whether we can undo them in DI and post if we have to do so to get back to scene referred state to do VFX and CGI. So you may prefer, if you're a VFX production, to use a curve that you can invert perfectly and not allow the photographers to mess around with. So you may use a log curve instead of a gamma curve for that function. Now, I've mentioned throughout the course this idea, which is not commonly discussed in color technology, but which I think is extremely important, the idea of picture rendering. That the higher the illumination in the scene, or the lower the luminance levels at display, the more you have to dial in adjustment to overcome the visual effects. And so again, to repeat or give you the third time, if you're in a really bright capture environment like outdoors in daylight, and you just mathematically reproduce those values with gamma exactly matching mathematically, it'll look like twilight if you display it at 100 nits. So we dial in some correction for that in picture rendering, and historically in HD, we would have done that using the gamma control. Experienced cinematographers, and if you want to use the word videographers, know how to adjust the gamma to make the best possible picture appearance at 100 nits in different viewing conditions. So typically, you will raise the gamma number for higher and higher scenes, although those adjustments are typically made based upon the experience of the cinematographer or the DOP, not really with theory behind it. And on a little personal note, it's one of my goals in my PhD research to put a little bit of theory behind that. So that covers the overall notion of what adjustments are available in the camera. And, part of my PhD theory research is to try to figure out what adjustments should be made to achieve the expected image appearance, like how to make 100 nits look like daylight, based upon the light levels at display time and at capture time. And so I was fortunate to find around the corner from PhD, FX PhD, an electronics shop that had quite a reasonable light meter for $130. So I bought one. So today we're shooting under illumination of about 750 lux, and that light level refers to the amount of light from the whole hemisphere above this measuring instrument, and all of that light is basically illuminating me. And that measurement is directly related through doing a base 2 logarithm to exposure value that would be recorded by a light meter like this one, which you'll notice has also got this hemispherical reflector to integrate light from all directions. So these are both useful as reflected light meters. And this is the official one from Sekonic, and this is the science version of the same instrument. And so let's just, for the sake of argument, go and look at light levels at a few different situations and get some notion of the range of illumination that we're expected to be able to acquire using digital cameras. We took a color checker outside on a bright sunny day in Sydney, outside FX PhD's offices at midday, and measured 60,000 lux, or if you wish, 60K lux, and captured the still. And our goal on displaying it is to make that picture look like it came from the sunny outdoors. 60,000 lux corresponds to exposure value 15 measured with a light meter. Now here's a shot taken in an interior at 150 lux, or about EV6, and that's considerably less bright than a typical television studio capture environment, but obviously an environment where you would commonly capture motion material. And finally, here's a candlelit environment. The illuminance is about 6 lux, EV somewhere between 1 and 2, measured with a light meter. And if you display this scene on a typical cinema class environment, the colors that you see at the display are comparable to the colors that you would have witnessed under 6 lux of illumination. So the picture looks fine without any processing. But if you bring in the outdoor shot mathematically correct into a very dim environment, the colors and the contrast will not look the same. It will be much less colorful and less contrasty, owing to the appearance effects that we've already described. So you've seen that there's a huge range of light levels that we want to be able to shoot or acquire imagery from. And we'd like to think of those light levels in logarithmic terms, because what's important is the ratios up the scale. So I'd like you to think of scale in this example of 1,000 to 1. And you could potentially overlay the absolute luminances on top of this scale. But this is giving you 3 density units or 10 stops of range. And into that range, we place a gray card, which is not quite 100 to 1 ratio. And we try to establish an exposure that gives us some headroom and some footroom above and below the range of reflectance values that are important to capture the particular scene that we want to capture. So we bracket the black and the white with some range above and below, just to protect our image content, to make sure we don't have to go and reshoot. Now, that entire scale I've drawn with equal intervals corresponding to the ratio 2 to 1, or on the other side of the chart, the ratio 10 to 1. And that topic of maintaining equal ratios is central to logarithms, which is a very important term and concept in understanding how photography or even display works across a wide dynamic range. And logarithms will be the subject of class 10. But meanwhile, let's segue into a bunch of other color spaces that you've heard of and learn about why there's different color spaces and different numeric representations of color.